Okay, so hello again. Welcome to the Programming Bootcamp. Hi, Laura.
Hi.
I think it's better if you put you on mute. Yeah, thanks, because some background noise. Okay, so let me show you the screen before I get started. And did I pick the right one? Sorry. Yeah. So you're seeing the main screen, right? So this is the Programming Bootcamp as usual, and we were in the list chapter. In the previous video, we saw previously we talked about the solutions of this the Q stack and mastermind exercises. And then if you look at the slides here, so first of all, by the time someone will look at the videos, it's quite likely that the order will a little bit change, and slightly the videos, the slides will be updated, so it won't be exactly the same. But for now, you can see that after the solutions, I have these two entries: mastermind to debug and debugging queue, and we're going to skip them now because maybe later we get back to them. But one of the reasons I have them here is because when we have these exercises, this is usually the first major part when people had problems and they don't know how to debug things. And I don't need to show it because you actually did it apparently quite well. And there are two major ways to find out what problems are with a program, how to debug a program, okay? One of them is the simple way, or not the simple way, but the I don't know how to say it. The way that can be done with any programming language, basically anywhere, doesn't matter what, is inserting these print statements. That what you did. So basically, what is programming? You write a bunch of statements, and then when you run the program, before you run the program, the world is sort of good. You ran the program, you gave it all kind of input, and then you got some bad output. That's the problem. Or there is the problem. And then you have to find the whole program was just steps of things moving around, conditions, loops, data moving around. And one of the ways, and the way to find out where the problem is just to go step by step over the whole code and see at what point does the program not meet your expectations. So you expected this variable to be, I don't know, 3 at one point, or to enter this condition because of some case, and it didn't happen for some reason. And that's the location of the bug. And then the one way to do it is to add more these print statements, seeing what are the values of the variables, whether we entered an if statement or not, whether we are in the loop or not, these things. And the plain way to do this is with the print statements. A more, let's say, powerful way would be to use the features of an IDE, for example, like PyCharm. And we're going to get that and look at that. But in this example, I guess maybe after this chapter, we'll look at PyCharm and all of these features. Now that we have enough material to actually utilize it well. And the reason we had these slides is to show how to insert print statements strategically or somewhere to allow us to see where the problem might be. Okay, so that's the whole thing there, which actually also reminded me about one more thing that I'm talking about now: debugging. Okay, I talked about debugging. Debugging can only happen when the program already runs. So if you try to run the program and it says a syntax error or some other reason it doesn't run, that's not yet called debugging. That's just finding out what the syntax error is. Now, if you just run the program on the command line, then you will immediately see the error, as opposed to seeing the program is running and then getting some incorrect answer. Okay. If you are in an IDE environment, like in PyCharm, then many people don't notice the real difference, because both PyCharm tells them that there is a problem. But there is a clear distinction between these compile time things and then logical errors I mean, even there can be different things. So for one type of error could be like you got to a place where you divided by 0 by mistake, and then it blows up Python, blows up your code. Or you have all kind of other errors that you use a variable that you haven't assigned yet, that we have seen. This can happen runtime. And these are sort of the easier errors to notice. The harder errors, the much harder error, is that you do some computation and it gives you 37, and you don't know that's not the correct answer because you did some experimental computation. It's even harder for people doing experiments who don't really know what to expect, and then it's really hard to notice, or it's much harder to notice. But that's also an important thing to notice, that when like everything seems perfect, just the answer is incorrect. Okay, and anyway, at one point I'm going to show you how to write tests, so you can write automatically test your programs. You still have to know what you expect, but at least it can be done relatively faster and better. Anyway, let's go to the next slide, which is sort. So here we have a list of planets. I can print them out. That's okay, nothing special. And then I can call the sort method on the planets. And if I print out the planets, then they are going to be sorted according to the ABC. Okay, or ASCII table actually, or Unicode table if you really want to go in depth. But that's basically. I can give this sort all kinds of, I don't know, all kind, yeah, a couple of parameters. One of them is reverse. So I can give it like this: reverse equal true. And by default, reverse equals to false. But if I give it reverse equal to true, then the same order, just in the reverse order. So it's still sorted by ABC, but instead of, I never know, ascending is descending. So one of them. I never know which one of which. Okay, so the other one. Okay, so this is sorting. Now what happens if we have a bunch of numbers, so a list of numbers, okay? I call them, I print it out, I call sort on them, the sort method. It will sort them according to their numerical values, okay? From smaller to larger. I can also give it a reverse, and then I'll get them in the reverse order, nothing special there. Now there is another thing that we haven't seen earlier, but you can do it there as well. You can also provide another parameter called key. So the name of the parameter is key, and then we give the value of the parameter is itself a function. So there is a function called ABS, or ABS, that calculates the absolute value of a number. So if it's -4, it will give you 4. And what this expression says is that sort the numbers according to their absolute value and give them in reverse order. So this time you see that it's -4 is between 2 and 7, because we are taking the absolute value of them. We are still getting back the original values, so we don't get the absolute values. We are just sorting them based on the absolute value. Okay. Right. Just like everything else. I mean, you can, when you have a bunch of people, you can sort them according to their height, according to their first name. You're still sorting the person, not the people, not just the names. Okay, so what happens if you have a list which has both numbers and strings? Well, in Python 2 it would work and do something really strange. In Python 3 it will just give us an exception, which is the right thing to do. So that's about it. So you can't sort things which are mixed. I think, yeah, I should clean this up. I think this slide is just a leftover showing again the key, but this time a different key. So this time we are checking the len. Okay, so let's see this one, because this is reverse. So here And now the output is separate. Okay, so we have the animals, we print it out, they are just the same animals, and then I can sort them. That's according to ABC. And then I can sort them according to their lengths. Okay, in which case the cow comes out, and the snail and chicken, then the elephant is the longest. It's longer than the snail, right? Okay, not biology here, just the length of the names. Okay, and I can also do the same with reverse. Okay, obviously, so it's saying. And by the way, you could put this part before and the key len after. So the order between those pairs doesn't matter. Right. Okay, so you can see that you can use the key again. Okay, well, I think we're going to skip this. So there are something called tuple, which are like this lists. We are going to talk about tuples later. Maybe we get back to this slide to see them. Okay. So sorted is a function that sorts. So it's almost the same as sort, except that sort would change. Well, actually the next slide shows the difference or explains the difference. So sort would sort the list in place, and sorted would leave the original list as it is and return a sorted version, a sorted copy of it. So if I go back to the previous slide, then that's what we see here. We have the animals. I can print out the animals. If I call sorted, then the S, the new S thing, this variable, is the sorted list, and the animals is the same as was originally. Okay, and this sorted also can get parameters like reverse and key. Okay, so just to say it another time separately, so sorted actually has now 3 parameters. The first one is a parameter that is based on location, so it's the first parameter, and then it has 2 parameters which are based on by name, that I gave them by name. And we'll learn about these giving parameters by location and by name later on when we're learning about functions. But just to clarify this, so this is why it has a name, because I decided to give by name, and this allows us to change the order. This one must be the first one because that's how I gave it. Actually, I could probably also give this a name. I just never know what the name is. So I would need to read the documentation of the sorted function to know what is the name of the data that needs to be sorted. Okay, and then I could put it in some other place if I gave it a name. It's not usually what we do. Okay, so that's the difference between sort and sorted. Okay, this we can skip. This is just another example of using a key equal to len, but this time unsorted. I probably need to get rid of some of these slides. They were just piling up, and then we don't need all of them. Here we have a string, and if I can call sorted on a string. So earlier we called sorted on a list. Now we are calling it on a string. What it does, it actually splits the string into characters, and then now I have a list of characters, and it works on that. So it will return the list of the characters already sorted. Okay, I guess I don't think I ever tried it, but I guess sorted can get anything that can be iterated over. So any iterable thing. And it will just return a list of these things. Okay, already sorted. So range that I mentioned, I think at least once or twice maybe, showed you a little bit. And now let's look at this one again. So the range function can get 3 parameters, and it would allow me to iterate over the numbers between the first, starting from the first, up till the second, but not including, by every second. So I don't know, the step being 2. So every second number. So it's going to be 11, 13, 15, and 17. So I'm jumping by 2. The third parameter is actually optional. Now I gave only 2, and it defaults to 1. So in this case, I say between 5 and 7, every single one, every one. So it's 5 and 6 because 7 is not included. And lastly, we can actually give it a single parameter, and it's a little bit strange because in this case, this is the upper limit actually. So it's not what we would maybe expect being the first one. No, this is the upper limit. This means that from 0 till 3. So it would be the same as writing range 0, 3. 3 is not included. Okay, but what is important? What is a slight difference that in Python 2, this would actually return the list of the values already, and in Python 3, it only returns an iterable, so only the possibility to go over the values. Okay. So okay, so people who come from most of the other programming languages are used to the fact that if they want to go over an element of an array, okay, something that in Python we call a list, then they will actually have to go over the indexes. So 0 till the last, the index of the last element, and then using that index fetch the actual value. And that's most of the programming languages, that's how they do it. The dynamic programming languages, so it's Perl and PHP and Ruby and Python, and JavaScript, allow us to actually iterate over. I'm not actually sure now about JavaScript. Anyway, they allow us to iterate over the actual values. So this is what we normally do for some variable in things. And this would just iterate over the values because I don't need the location. And my standard example is that when you go with a shopping list, it doesn't care, you don't care in which location some item is. You just go over them and buy them all, right? So in many cases, we don't care about the location of an item. And so far what we saw, that was how it was handled. But now I'm showing you a special case when you do need the actual location of something. So for example, or I don't know, they don't show you now the case yet, but I will soon have the case when you actually need it. Now I'm just showing how to use it. So in this case, I'm going over now the numbers, so 4, and I just use the variable I. I take the length of the things, length of the list, and I go and I call range on it. So because this len is 4 in this case, because it's 4 elements, it's going to be range 4. So it's between the numbers 0 till 3 actually, which are exactly what we need, the indexes here. Okay, so now I will iterate over 0, 1, 2, 3, and then this construct allows us to access the specific element that we know already because we know how to access elements of a list. And so now we can print out the location and the value. And sometimes it's useful. There is another way to do this, or something like this, is the enumerate function. So in this case, I have a list of planets. I call enumerate on it. And then in the for loop, I actually iterate over on 2 parameters, or 2 variables. And what Python does in this case, that on every iteration, it will put the index in the first parameter, in the first variable, and the value in the second one. And here I was already better because I was calling this variable idx, so it's not just a single letter thing. Okay, the names don't matter. So idx and planet here they don't matter. They just put in the index first and the value second. And so this is what it prints out. Okay. And here are some explanation just showing what enumerate is. It doesn't really matter for now. Okay, the point is that this is another way to go over, to iterate over a list, having both the index and the actual value. And I think these days I probably would prefer this one, not the previous one. The previous one is still sort of like the style that other programming languages provide. And well, it's fine, but Python has a probably better way to do it with the enumerate. There are all kind of operators on lists, so you can actually multiply a list. Okay, sorry, I have to drink a little bit. So you can multiply or repeat, actually. That's not exactly multiplication, it's repetition of a list. So here I have a list here which has 1 and 2 in it, the words 1 and 2, and then multiply it or times 2, then I will get a list which has 1, 2, 1, 2. And I can also add together lists, which just put the content. So maybe I should put here 2 elements to be clear, but it just concatenates the list to be one more longer list. Yeah, actually.
Sorry, yeah. With the previous one, with the concatenation, does it always? So here, the order of the 2 operands matters, right? Because the second one gets appended to the
So in this case, it matters. In this case, it doesn't matter. Okay.
Right.
Yeah. Okay. Yeah, it's well, that's an interesting thing, because for numerical operations, the plus the order of the order of the operands in plus doesn't matter. Yes. Okay. Yes, it's actually a very nice feature of Python that allows us to write these things, and actually we can write on our own objects, on our own later on when we talk about objects. You can do it on your own stuff, and it can be really nice. So I guess if you have 2 chemical parts and you add one to the other, it might be different than if you add the other one to this one. I have no idea. I failed all of my chemical exams, so it's okay.
So there are examples for that.
Good. Okay. Good. So list of lists. So we actually had a glimpse on this already, but we can see it now more, or introduce it officially. Here we have a list, just values, nothing special here. And then now I create a list, a new list, which the first element is actually a list, another list. So now if I print out Y, I get this output, in which we can see that the first element itself is a list. So it's like a 2-dimensional thing, except it doesn't have the second dimension in every place, because this has only 1 dimension. Okay, so we can access the internal list like this. So Y in the square bracket 0, this is the first element of Y, which is just the internal list. And then because X0 is the first element of this, then we can also say the same here. So we can have multiple of these indexes, and then they go deeper. Okay. Now you might think about, and I mean, usually people already start to think about, oh, matrices and how much fun, and so especially people who want to do all kind of number crunching on huge data structures. So this is not that. Okay, these are lists of lists, and they are super flexible in Python, but they are not what you usually use when you have a lot of data. When you're going to get them and talk about NumPy, NumPy has its own data structures, its own arrays, not lists. They call it array, but it's basically the same. It's a vector, and they can also be used as two-dimensional matrices, and you can also use them as any other number of dimensions. So that's the huge part. Here, I mean, you can do it, but it's much more difficult to do this here. On one hand, on the other hand, it's much more flexible. So here, you don't need to be the exact same dimension every place. In NumPy, that's how it works. Different goals for the different things. List assignment. Okay, so well, this is a standard, sort of a standard question, or used to be in job interviews that you have two variables and two values in the variables, and how do you swap the values. And in basically most of the other programming languages, again, usually not the dynamic ones, but the other programming languages, for this you need a temporary variable, because you can't take the content of this and put the other one, because then you lose the other one. So you have to put it aside and so on. In Python, you don't need all that mess, because you can write this way. So first of all, you can assign two values to the two variables in one statement. And you can even write this way. So you say y goes into x and x goes into y. And it sort of happens in parallel. Okay? So Python figures it out how to do it. So it really will swap the two values. And it's primarily going to be interesting, this kind of an assignment, that you can have more than one values on the left-hand side. It's primarily interesting when we're going to have functions that return multiple values, and we would like to grab them and put them into variables. Okay, but it's so this is one of the flexibilities that are provided that make all the extra memory that we are using for variables necessary. Okay. Okay, so this is just a link to the documentation of lists, of data structures in general. Not that interesting for now. Tuple, so I mentioned briefly what a tuple is. Maybe we can get back to it, because now we're going to have the exercises. So a tuple is basically an immutable list. So a list that you can't change. And visually, it looks just like a list, except instead of square brackets, you have just regular parentheses around it. Okay, so this T is now a tuple. And you can do anything on it that you can do on a list unless it changes the list. So you can't sort it. You can use sorted on it, but you can't dot sort, because the dot sort would change it. You can't append to it. You can't pop from it. You can't do all of these things that would change it, because it's immutable. And there's not a whole lot of use of it, but there are a couple of places where it's actually nice that we have a data structure that it looks like a list, or more or less, but that we know that no one will be able to change it. Okay, and let me just quickly try to go back to I had somewhere else this tuple in a sort tuples. Okay, so I get back here. So here now I have a list. Okay, so this is a list, because it's square brackets, of tuples. Okay, so each one of these is a tuple with 3 values. And if I print them out, this is how they look like. So it's one after the other. If I call sorted on it, then it will be sorted by the first element of the tuple. Okay, and then I could, whoa, these are all kind of things that we probably shouldn't see at this time. But let me just show you this. So this time here, I'm sorting it, but based on the first on the index 1 of the tuple. So tuples are already also indexed by 0. So this is the second element, number 1, and these are the A, C, and B. Okay, whatever they are. Okay, and this is the key. So I mentioned, right, that the key is the name of the parameter that gets the function that decides how to compare values. And this is just a function. So just think about it as a function that will, based on whatever it gets, it will return the element 1 of it. So this is basically saying sort the students, and when you compare them, compare the element 1 of them, which is the A, C, and B in this case. Okay, and here I have the same, just comparing the numbers in this case. So, well, we haven't learned all of this yet, but and this lambda and all these things. So don't worry about that. I'm not even sure why I put the slides here, but good. So we are done with the tuples, and now the exercises. So I'll go over quickly the exercises to explain them, that I'm not sure that the written explanation is that good. So the first one is that you have a list of colors in your program, and I would like you to show me a menu on the screen. So this is what you will print. Okay, you have a list, blue, green, yellow, white, and you show me this list, and then you wait for me to type in a number, 1, 2, 3, or 4, and then when I typed in, you print out, okay, you picked, I don't know, yellow. Okay, so that's sort of the basic thing. And then you can have extra, whatever I say it extra credit, but doesn't matter. You just have extra fun. Okay, you can have extra fun for checking what happens if the user types in something incorrect. What if the user types in a negative number or a floating point number or a string? And how do you deal with that? Can you deal with that, or what do you need to do? That's one step. Then you can also extend this idea by saying, okay, so far it's so good, but and the program doesn't have to do anything else. It's just a menu, but and think about it as a part of a larger program, that the first thing that you ask is the color. And then at one point your users get fed up of always getting the menu, and they say to you, okay, I would like to be able to give the number on the command line. And then you don't need to, if I give a number on the command line, you just pick the right color, and you don't show me the menu. And okay, so other people will want to give you the word yellow. So can you handle that, or how can you handle that? And if you manage to handle, then what will happen if someone types in yellow like this? Will that still understand that's the same yellow, or will it complain? So these are all kind of ideas to try to solve. Okay, and yeah, if you have any more ideas for improvement, just go ahead. That's part of how people learn programming, that they pick some idea and then try to make, okay, how can I do this, or how can I do that? Okay. In this exercise, we're still not having, still not dealing with files, with external data. And at one point, we're going to combine all of these with external data. So all these basic things will be useful. So in this case, I have a list of numbers, okay, which is called numbers, okay, just like this. And I would like to know how many times each digit appears. So in this case, 0 appears once. So there's 1 0 here, I think. 1 appears 3 times. 1, 2, 3 times. Okay, so this is the output. So actually, I think for this input, this is the output. But whatever list you have, it should be able to give this output. Okay. Okay, this is not, I think, that much of a fun, this exercise. I think I have a list of strings. Each string is words and spaces. Okay, and I would like you to create a list combining all the words. Okay, so that's the first step. And then create a unique list where when each one only appears once. Okay, and then another exercise. Oh, we have plenty of exercises here. That's a fun part. Okay, count words. Okay, so yeah, so count words. We have a list of words again. It could be actually anything. I mean, you see that there's just strings basically. That doesn't matter. So list of strings, and count how many times each string appears. So moon is twice here. Okay, gas is once. Okay, it's quite similar to the digit counting, but first solve the digit counting, because this gets a little bit more complex. At least for now. After the next chapter, it's going to be easier. Okay. Okay, I'm not sure. I don't even remember why I have this exercise here, but can be a fun one. So you get a number and print out if it's a prime number or not. It's more like writing an algorithm. I don't know how much it deals with all this rest. And then here is one for you. Okay, so DNA sequencing, whatever it is. Okay, so we have all these nucleoids, not nucleotides. Okay, I know, whatever.
Nucleotides.
Nucleotides. Okay, so then we have these 4 letters. I don't care. Okay, that's the point. Okay, so that's that's actually an interesting thing. And so chemists, biologists, they have all these interesting things, words. I think when they start programming, if they can forget about the special meaning of these things, it's gonna be easier. It's just letters. I don't care that it actually has some meaning. So, and then you can think about a more generic solution, probably, okay? So I think that's a good advice. Anyway, so we have 4 letters here and a string like this, okay? Which has all those 4 letters, but somewhere you have X's here. Okay, so I was told that this is like a standard way of marking things that are, I don't know, either unknown or some garbage or whatever. Okay, so the first thing is to create a list from a string like this that contains only the right letters. So remove all the places where you have an X, just to get rid of them. And then sort them by the, and then sort them, okay? Or I don't know, about split it up to this, and then it can be sorted to get the following. So, okay, I should explicitly say this, sort them by lengths. Okay, I need to put it in the slide. So sort them by lengths, okay? That's sort of the exercise here, okay? So that's it. Any questions with the exercises?
No, I think they're quite straightforward. Obviously, I'm sure I'm going to have questions during doing the exercises, but we'll get to that.
Okay. So thank you very much, everyone, for watching and you for participating. And then we are going to. So now you're going to have a long break till you manage to solve all the exercises, and then we get back to the next chapter, looking at the solutions, and then to the next chapter. So thank you very much, and see you next time.
See you.